our two main measures of center that we are going to use are mean and median. Okay? So for mean, that is our average, and it is going to be when we add up all the values and divide by the number of values. Okay? So for mean, that's what we're going to do. For median, it's the middle number. You have to put all the numbers in order and find the middle number of those numbers. Okay? So, here's an example. Okay, and I want you to see the difference between mean and median and when one might be better than the other to use. Okay? So, the prices of houses in a neighborhood are listed. Okay? And this I did a few years ago. They're probably worth like 50% more now because house prices are going through the roof. The Blackburns, $125,000, Bobbitt's, $150,000, Walker's, $100,000, Norvay's, $200,000, Longworth's, $150,000, Newmark's, $175,000. So we need to find the average price of the house in this neighborhood and the median. Okay, so for the average, I'm going to use Desmos. You can use your calculator also. Let's see. Let's get rid of this stuff. Alright, so I would just add all of these. Yes, add all these up. You need to be adding these up. Yes. Okay, what are you going to get? How many? 1, 2, 3, 4, 5, 6. Okay? Alright, so Owen says 150,000. I agree. So average is 150,000. Now, if we want to know the median, we have to put the numbers in order. So if we want to know the median, lowest is 100,000. Then we got 125. We've got two 150s. Make sure you list them twice if there are two of them. We've got a 175. And we've got a 200. Okay, so when we find the median, we're finding the middle number. Is there a middle number for this one? There's not, because we've got 6. So like one way you can do this is just kind of like cross them off. 1 and 1, 1 and 1. You would end up crossing them all out, right? So when you have an even number, you're just going to average the middle two, which in this particular case is just going to be 150,000, right? Because if you add 150,000 and 150,000 divided by 2, you're just going to get 150,000. They are the same. All right, so in this particular neighborhood, average and median house price are the same. Okay, so we don't see any difference there. But the Cockrams are moving in, and they're going to build a house at the end of the street that costs $675,000. What is this going to do to the median and mean prices of the neighborhood? Okay, so if we are looking at the Cockrams, if we're adding 675,000, that raises our total to 1,575,000. So if we divide 1,575,000, if we divide that, what number should I divide it by? 7, because I've got 7 houses now since I added the Cockrams. Okay, so the mean is 225,000. But if I go up here for the median, so with that list, I would just be adding that 675,000 to the end of the list. So now if I go through and mark them out, mark out this one, here, 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 here. I do have a middle number this time. What is it? 150,000. So my median would be 150,000. Now, sometimes the median changes whenever you add a bigger number, but it's just going to go up to the next number that was above it, right? So, like, even if, you know, it might have went up, if we added one more expensive house, the median will go up to, like, in between 150 and 175. But it's not going to make huge jumps whenever you add a more expensive house. But the mean is now 225,000. Now, does anybody in the neighborhood have a house worth 225,000 besides the Cockrams? No. There's only one house there that's worth more than 225,000. So which one describes the most common house in this neighborhood the best? The mean or the median? The median. Because most of the houses are around 150,000. A little more, a little less, right? None of the houses are worth 225,000 except for the Cockrams house. So what we see with mean and median, mean is affected strongly by outliers. So if you have somebody come into your neighborhood and build some sort of mansion whopper house at the end of the street, unless you already live in a neighborhood full of mansion whopper houses, then it raises the average house price, but it doesn't change much about the neighborhood, right? The neighborhood still has all the same houses it's had before. But the mean price will really go up really high. But the median gives you a better idea of what houses are like in that neighborhood, right? So, you know, this is something that's really important because sometimes they might give you an average, and it might be misleading. The average might be misleading because there might be one really, really, you know, wealthy person on the street that has a huge house, and most houses are not like that. So you may see that happening here, okay? All right, so let's look at something super exciting, length of math textbooks. All right, so they give you the number of pages in all of these different books, and they want you to find the mean and the median for these. Let's see. Okay, that's different. Let's look at. All right, so for these two, I want you guys, I'm going to cut my screen off while I do this. I want you guys to find the mean and the median for this set of data. Okay? So, mean and median. So, look at math books first, and then look at history books next. for the math. Yes. Let me show you something that I need to watch out for if you're using the calculator. I prefer to use the calculator sometimes, but do watch out for this right here. Like if I'm finding an average, let's say I got 4 things. If I'm doing 5 plus 8 plus 9 plus 1 divided by 4. Alright, if you type it in like this, if you add the 4 numbers, 5, 8, 9, 1, and 4. If I hit enter, I get 22.25. Is that right? Should that be the average of 5, 8, 9, and 1? No, it doesn't make any sense, right? It's bigger than any of those numbers. What did I do wrong? You've either got to have parentheses, 5 plus 8 plus 9 plus 1, so that everything there will be added first, and then divide by 4, which is 5.75. That seems right. Or you got to do 5 plus 8 plus 9 plus 1, hit enter, and then divide by 4. So be careful with that. If you're getting a number that doesn't seem to make sense, if you're getting an average that's bigger than any of your other numbers that are even in the list, then you may have done that part wrong. So be careful with that. And always ask yourself if your answer makes sense. Several years ago, I was teaching a class a long time ago, and we did average shoe size, and some girl got like 37 as her average shoe size. And I was mostly concerned. She had done that right there. She had done the first mistake I made. She otherwise was doing it correctly. My main concern was she did not realize that it obviously had to be wrong. So I tried to point that out. Have you got median? Find the median.
Median you do.
Median, they've got to be in order.
Okay.
So, yeah, put them least to greatest and then find the middle number. Yeah, so if you've got, so not only you've got 10 numbers, so what you'll do is the middle 2 numbers, which are right here, you want to add those together and divide by 2. So get the average of those 2 numbers. Yeah, divide by 2. Because you're just averaging those 2 numbers. How many do you have here? 6 and 5. Yes.
So when you get to the median, and you get 2 numbers,
So whenever you, and it's going to happen on that first one, if you get to the median and you got all these numbers, and then you got like 784 and 821 here in the middle, and these are your middle 2, you're going to average just those 2 numbers, so you will add them together. I'm just making up numbers, so you use the numbers you have right there, and divide those by 2. divide by 10. Let's see.
Yeah.
I may have typed 20 wrong here. Oh, yeah, I put a period instead of a comma. Okay. What'd you have as your average for the math? You're right. You're right. Sorry about that. All right, once you've done the math, go ahead and do the history for me. I've already done both. Just hold on for a second. You add up all these numbers and divide by the number that there are. So averages. You've already done the average, which you have correct here. That is. I don't know who decided that we should have 2 words for average. And mean be the one that we only use in math class, because the rest of the world says average. Why don't they just call it average? Oh, it makes a lot more sense. But I was not in charge of that, guys. Sorry. We gotta play by their rules. It does not seem like there needs to be 2 words for that. All right, I think most everybody has the first one at least, and several of you have the second one. So we're going to go on and look at these. For math, you should get 783.9 as your mean. And median, you should get 811. If I typed everything in right for the history books, what are the 2 middle numbers when you do that? So 794 and 828 end up being your middle numbers. So you're going to do 794 plus 828.
Oh, I got 775 and 794 as the middle numbers because there's 1, 2, 3, 4, 5, 6, 7, 8. And then the 2.
Yeah, there's 10 numbers, so maybe you left off a couple there. All right, and so for history, if I did it right, tell me if this looks right. I got 801.625. Is that what you guys are getting for the mean? No? All right, let me look at mine. I know, what am I doing here? Goodness. I mean, I'm cheating and using Desmos is what I'm doing. Because I can do it faster. I'll show you guys how to cheat and do that in a second. But obviously, you might not want to do it. Because, now that one's been right, I think. There's 1, 2, 3, 4, 5, 6, 7. Okay. 1256, 861, 1264. Oh, I wrote the wrong one down. 963.285. Okay, I think I just wrote the wrong thing down. So, 963. .285. Maybe. I was not rounding very good there. And then the median, 861. In this particular case, there is a middle number, so when you put them in the order, 861 is in the middle. Okay, so let's, I'm going to show you guys what I was doing. I was cheating. I was hiding it from you there. It's not really cheating because this will be on Calculator Active, but I do want you to do a couple of these where you're actually calculating them by hand so you understand how to find the average. So what I did is I entered my list here in these parts right here. So I have M equals and the square brackets, and just listed all these separated by commas. I listed all of these right here and separated them by commas. Then if you just type mean, parentheses, H, it'll give you the mean for the history books. If you do median, it'll give you the median. You don't have to put the numbers in order whenever you do it that way. So it's kind of nice. We'll do a couple more medians by hand because there's a chance they might give them to you not on the Calculator Active section, but most of this stuff you'll see on Calculator Active section. And then same thing for math. I did the same thing there. Right. The other really good thing about doing this on Desmos is if we look at the next slide, it's the same list of numbers, but it says over here, let's say that a new math textbook comes out with 1,200 pages. Calculate the new mean and the new median. So if you've done this on Desmos, look at all you have to do, right? All you have to do here is just add 1,200 to the end. Okay? So the new mean is going to be 821.72 repeating, and the median is going to be 828. Notice both of those increased here. Our mean went up from 783 up to 821, so it increased by about 50. Our median only went from 811 to 828, right? 1,200 was significantly longer than any of the rest of the books. So we added that. Which one did it affect more, the mean or the median? No. The mean went from 783 to 821. That's up by almost 50, right? Whereas the median went from 811 up to 824. So it just increased like 15 or 17 there. So notice the median was not as strongly affected by that outlier that we added. So keep that in mind. All right, let's do the same thing with the social studies book. I'm going to do that up here so we don't have to calculate everything else by hand. What about if a textbook comes out with only 435 pages? So let's talk first, what do you think is going to happen? If we got 435, what's going to happen to mean and median? They should go down because that's less than we have for any of our other books here. Make sure that you are paying attention and not looking at something else on your computer because some of y'all seem to be staring at your screens a lot. All right, so our new mean here would be 897.25. The median, 841.5. And that was down. The old mean was 963 and then 861. So this was from 963. This was 861. So again, which one? Oh, sorry, that's the wrong. 963, 861. Okay, which one? They both decreased, but which one decreased the most? The mean decreased by quite a bit more. Yes. I think I have those in right. Did you guys also get 783.9? You've probably just typed one number in a little bit wrong. All right, so let's do this again. All right, let's make this conclusion. So an outlier is an individual piece of data that is significantly different from the rest of the data. We actually, when we get to the box plots, we'll talk about what can make an outlier. Like, you can have a rule that will qualify something as an outlier. For right now, we're just going to say it looks like a really big or really small number, right? The mean is more sensitive to outliers. The median is less sensitive to outliers. What does that mean? What does that tell us that something is sensitive to outliers? What does it mean for if we say that a person is sensitive? So if we say, don't mess with Peyton, he's kind of sensitive. That means if we say one mean thing to Peyton, he's going to cry, right? So that means he's very much affected by the things people say to him, right? I picked Peyton because I don't think he's very sensitive and could take that. Yeah. So someone who is sensitive is going to react big to something, right? But if you are not sensitive, like Owen, I would say is not. I don't know. If you call, have you tried calling Owen a liberal? He might be more sensitive than we think. He's not good. He might not cry, but there's going to be a big reaction. He was going to fight Coach Wood in the hall the other day. That was a poor choice. But if we pick somebody who is not sensitive, then they're not going to react big to anything that you say, right? They're not going to have a big reaction to everything. So a mean being sensitive to outliers means that if you put an outlier in there, the mean is going to change a lot. But the median is less sensitive to outliers, so it might change, but it's not going to change as much as the mean, right? So that's what this means here. So we are going to find the mean and medians of each data set. And for sake of time today, let's split these up. So this first row right here, I want you guys to do set 1. Second row, I want you guys to do set 2. Here, I want you guys to do set 3. How many do I have? 4 right here, 5, you 2, and 6 right there. And that's, I do have a 7. And everybody do 7. Yes. First, second, third, fourth, fifth, sixth, everybody do the last one. Okay? So you got 2 problems to do. Yeah, I was really nice to you and I already put these in order. You're just doing mean and median. They're already in order for you. These should be things you've already done before. You're going to add all the numbers together and divide by how many there are. And then you're going to find the middle number. It's on your paper, yeah. Number 5.
I didn't. 2509.
I need to get out this smoke.
Oh yeah, I put 11. I put plus 11. My bad. What was it?
Yeah, that's fine. 4. Huh? Do them all individually and then check with each other, because that way you won't make a mistake. Like, if you make a mistake, you'll probably catch it.
Yeah, I got 26. You got 26. Sorry, you're gonna move me.
Zane, make sure you do it as well. Because, like, all Jane's got to do is type in one number wrong, and then you're going to miss it. Like, she's going to miss it. And the whole row, she didn't miss it. So you're going to have it done. But if all four of you get the same answer, there's unlikely you all make the same mistake. You get 1 and 7 is number 7. Go ahead and do 7. Everybody needs to do 7. I'll do it. Yes, one day. Whenever I get time, I'll think about it.
No, I'm not gonna try that again. I just cleared it out.
Or for you to say, what number 23? Or I'm here. All right, has everybody had a chance to do the one for their group? Yep. All right, everybody's checked with your group to see if you guys have got the same number. Okay. All right, so I know we haven't all done all of these, but write these down as we go because there's something I want you to see from these problems. So over here in the first row, what did you guys get for the mean? Okay, that's what I got too. What about the median? Good. All right, for 2, what did you guys get for the mean? 27.6. And median? Okay, that looks good. That's what I've got as well. All right, so copy these down for me. For 3, what did you guys get for the mean? Uh, 57,714 point something 286. I don't have a decimal. I don't know if that's why. I don't know if that's because I just rounded it to the nearest whole number, or if it's because there wasn't one. But let's just say we round it, and we'll get the same answer. Okay? Because I did not work it out right now. I worked this out earlier. And what about for the median? 60,000. That is correct. Because you got 1, 2, 3, 4, 5, 6, 7 numbers. So that fourth number right there is your middle number. That's right. Okay, questions on the first three? I know we weren't all working all these out. All right, row 4, mean, 5.3. That's what I've got. And median, 5.15. Perfect. Right here, you got a case where you got 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4, 4 and 5. Right here, these are your middle two numbers. So you have to add those together and divide by 2. Okay? All right. Let's see, for 5, 61.6, and median, okay, set 6 down here on the end, and, yeah, 32. Okay? Oh, sorry. Okay? And then everybody was supposed to do the last one. What did you guys?
146,333.
Okay. And then median. Okay, so what I want us to do, yes, with the mean, that's fine. I just wrote mine. I rounded it, I guess, the nearest whole number whenever I write this down, so that's fine. All right, depending on how specific they were wanting me to be, that would be good. Okay. All right. So here's what I want us to do. I want us to think about each data set. Okay. So, whenever we have data sets, we might have what we call outliers, numbers that are a little higher than what we would expect or a little lower than what we would expect. So, if we look at that first set, do we have any that might be kind of outliers, kind of higher than normal? This is the number of hours exercising per week. 10 and 11, they're a little high, right? So, we do have 0, which is low, but it's right next to 1, right? So 0, 1, plus we're talking about exercising every week. I would actually expect there to be more zeros than there are, right, out of lots of people. So 10 and 11, the next lowest is 7. So these are a little bit high. Notice here, we had high outliers. Our mean was higher than our median. All right, for set 2, we are looking at the weight of 2-year-olds. 35 and 40. These are some big 2-year-olds right here, right? Henry's 5 and he weighs 42 pounds. So they're real big. And you can notice right here, like everybody else is pretty close up. 22, yeah, they're the smallest, but 24 is right next to them, right? There's not going to be a lot of difference between those. But 35 and 40, these are big kids. This is like I was whenever I was little. Large children. Here, or my nephew, Nathan. He's in kindergarten, and he's already outgrown Hunter. Which Hunter's tiny. Hunter's the littlest in his grade. But, so, had high outliers. Which one is higher, our mean or our median? Mean. Okay? Let's look at annual salary of engineers. At 42 is a little low, right? Everybody else is 55 or better. 55 to 65. 42 is kind of low. All right. So which one is, notice this case, what do you see about the mean? The mean is lower this time than the median. All right. 40-yard dash. 7.2. This is like if they got Miss Hyde out there to do the 40-yard dash. I doubt.
It's actually faster than Keenan.
I doubt I could outrun Keenan.
I guarantee you could.
Y'all haven't seen me run.
It.
And you probably won't. But 7.2, that's super slow. Even though the rest of these times, these are fast times, aren't they? For 40s.
4.5 is about NFL.
Yeah.
And then 5 is about college.
Yeah. These are pretty fast times. So this guy right here, he probably is out of his league right here. He's probably a linebacker trying to run it. All right, but we got this high number. Notice the mean is higher. All right, U.S. Senators at 34 is a little low. Notice here, this time, it's actually the median that's lower on that one. So, we'll talk about that in a second. Size of household. How many people live in your house?
24 is a lot.
We got 19 and 24 right here, so we got like the Duggards here in this particular count. So, 10 and 12 is a lot of people, but 10 and 12 is a lot of people. 5's not too uncommon, even 6 maybe, but really we've got 9, 10, 11, 12, 19, 24. Those are all pretty big numbers, right?
2 isn't super big either. 19.
Yeah, 2 is small, but it's right next to 3, right? So if you only have 2 people that live in your house, that is smaller than normal, but it's not uncommon to have 4 people living in your house. In fact, that's probably very common. So yeah, we got really, this 10, 12, 19, 24, that's a lot of people in one house. So notice our mean is also higher there. And then we've got house prices. Got any that looks uncommon there? That's $45,000. This is the house on the end of the street that has just like fallen in and it's not doing so hot, right? Nobody's taking care of that house. Notice here the mean is lower. So what we should see here in all of these cases except for one, the mean follows the outliers, right? So if we have really low outliers, it pulls the mean down. So if I give a test and everybody makes an 85 on the test except for one person who makes a 10, that 10 is going to pull everybody down, right? Same thing is true, though, if I have a high outlier, right? If I ask everybody in here how much money your parents make, and then we have Donald Trump Jr. walk in, for the lack of other people that I know are a good example of lots of big money, and we add them to the list, that's going to make our average really, 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 really high, right? Because they make so much money that all of our money combined probably doesn't even touch their money, right? So what we should be seeing here is the mean is going to react to those outliers a lot more. It doesn't always happen in every case. I gave you set 5 on purpose so that you could see it doesn't always happen, right? So right here for this 34-year-old senator, that's very young for a senator. I'm not even sure the actual age you have to be a senator. Someone will look that up real quick. Age for a U.S. senator. I know it's 35 for president.
At least 30 years of age.
30. You got to be at least
You gotta
30.
be a US citizen for at least 90 years.
Okay, so senator,
233 years.
333 years.
233.
That's gotta be
That's got to be
right.
wrong.
I'm talking the age for U.S. Senator popped up 233 years.
Maybe like how long is the
Maybe that is like the age of the Senate
How
itself.
old do you have to be the president?
35.
Have you ever had a 35?
No. And you probably won't, but good question. Google that. Who's the youngest president? You guys should know who the oldest president is. Biden. Biden is the oldest president we've ever had. All right, here's another fun fact. Before Biden, who was the oldest president we ever had? Trump.
What y'all talking about right now?
These guys
Huh?
are in their 80s, early 80s, late 70s.
So, when you think of like George Washington as being super old because it was so long ago, but Biden is the oldest president we've ever had, and Trump is second, which is kind of crazy. Think that. Well, that's a matter of opinion that we won't get into. We're going to stick to some math today, Easton. We'll stick to math today. We won't get into a political debate. I have no question that Owen agrees with you on that statement, but let's not get into it. All right. Owen, cut it off. We're not getting you started right now. We're curious about ages. That's all we're talking about is ages right now. We are not derailing this. We got 10 minutes left. Okay, so let's go to the next slide with some conclusions. All right. I thought age of president was going to be relatively.
Well, it's over.
Yeah, I know. You're right. Actually, Easton started that one. All right. he just drug Owen in because he knew it would be easy, right? All right. Okay. If the data has high outliers, the mean will be pulled up. Typically higher than the median, but not always. If the data has low outliers, the mean will be pulled down. The median may change. It may be pulled up or down, but it will usually not change as much in most cases. All right, so let's look at these graphs right here. In each situation, which will be higher, mean, or median. So we're looking for where our outliers are here. Okay? So where on this first graph, on our rainbow graph here, do we see bars that are kind of out by themselves? Is it to the left side or to the right side? It's over here to the right. We kind of have some outliers here. Guys, quiet. Okay? We kind of have outliers here. So, outliers are going to pull the mean up, right? So, mean would probably be highest here. What would you say about the second graph, days between failure? We still have this like sort of tail over to the right. We'll talk about what that's called tomorrow. And so I would still say the mean would be higher because the mean is going to be pulled up. What about this histogram density graph that we have right here? This has more of like a tail to the left, so the median is probably higher in this case because the mean gets pulled down by those lower data points. What would you say for this one right here that's called a frequency histogram? You got like a couple little bars right here, but you also have like this one's a little higher than this one. Is there an obvious outlier on either one of these? This is what we call, we're going to talk about this tomorrow more, but this is what we would call a normal distribution. It looks kind of like a heel that's about the same on both sides. And so this one's thrown in kind of as a trick. I would say they're about the same here. Whenever we did that first problem with the neighborhood, and our mean and median were exactly the same, it was because our data was really regular, right? We had a few in the middle, we had a few lower houses, a few higher houses. Yes. Normal distributions are really important when you get into like some higher level statistics. What about the last one here? Definitely down here, we've got those lower outliers. That pulls mean down towards those lower outliers. So for that, we would say the median would probably be higher. Okay, so tonight you are going to have a worksheet, and here is something I would suggest for you. Actually, I was nice to you on these. Quiet, please.